Alright, today's lesson will be about sinusoidal functions. Sounds complicated, but it's not. It's pretty much transformations, which most of the stuff I know you get already. So it's kind of going to be a familiar review. Alright, first things first, let's go and talk about each one of these variables. So we have A, B, C, and D. These are our transformations, and I'll show you what each one of them does. So for the first one, let's look at A. That's your amplitude. So our amplitude, it stretches or compresses the minimum, maximum, or what we call humps. And notice that when I stretch, when I increase A, the center of gravity, that line in the middle, that's not changing. All that's changing is our minimum and maximum is going up and down. And so when our A is bigger than 1, when it keeps getting bigger and increasing, you see our minimum and maximum just keep stretching up and down. But when it's a fraction between 0 and 1, that's when it compresses. So compression here, and then stretching bigger than 1. And if A is negative, it will flip over the x-axis like that. Also with the amplitude, as I'm moving this up and down, you notice, okay, so look, if I move it here, I'll say it's 2, the amplitude is 2. What that means is that's the distance from the axis here to your maximum, and the axis to the minimum. So from here to here is 2, from here to here is 2, so from the minimum to the maximum, it's double, it's 4. If I change this to 3, now I'm going from the axis to 3 up here, the axis here to 3 down here, so from the minimum to the maximum is 6. All right, for our next variable here, B, that's our period. So our period is the number of cycles or waves over 360 degrees, or 2 pi if we're working in radians or degrees. Right now we're working in radians, so over 2 pi. And you can see that on our graph here. We're going from 0 to 2 pi. Think of 2 pi as 360 degrees. That's one complete cycle. So as we increase and decrease our period, it's going to stretch or compress our graph. So like it says here, if B is bigger than 1, the graph compresses. And here we go like this. See, it's getting pushed and pushed together, so we get more humps. And a way to look at this is, let me write this down for you. We're seeing how many cycles are over 2 pi. So if it's one cycle, it's just 2 pi. So we have one cycle. If our B is 2, what that's saying is, you can see here, B is 2. Now we have 2 cycles over 2 pi, which means one full cycle is over pi. And look here, so from 0 to pi, that's one full cycle. And then from pi to 2 pi, it's another full cycle like that. I can go even further, 2 pi over 4, that means one full cycle is going to be over pi over 2 like that. So if I increase this to 4, look at that. We have more waves because one full cycle now is from 0 to pi over 2. So now we have 4 cycles here, 3, 4. Now it says if B is between 0 and 1, it will stretch, because now we're going to have less cycles. So right now, here's at 1, there's, one full cycle. If I'm at a fraction like this, 0.5, you see that? This is only half a cycle now, be over 2 pi. So we have one big hump. As we keep getting smaller, closer to 0, you see that stretches even more. Now for the next one, this one I know will look very familiar to you all. It's the X in the parentheses. So this is the horizontal shift. So it shifts the graph left to right. When C is bigger than 1, it shifts it to the right. When C is less than 1, it shifts it to the left. So look at that. When C is greater than 1, you see that? It's shifting to the right. Whee! It's like we're at the beach. Yay! Oh, seasick. Oop. Okay, slow down there. There we go. And if it's negative, it's going to go that way to the left. Yeah, I didn't take my seasickness pills. And the last one, it's going to be a vertical shift. I move it up and down. Let me move that back to 0, or sorry, 0 here. I move the graph up and down like so. When D is positive, it goes up. When D is negative, it goes down. And look, see what it says? It says that it moves a sinusoidal axis, that horizontal line in the middle. That's what's moving up and down. And it's moving the whole graph with it. I call it the center of gravity. So for example, if I move D to be 2, now you'll notice that center of gravity is up here at 2. So the whole graph has been moved so that now it waves, the whole wave function is over 2. I can make it, -1. Now the whole wave function is over -1, like this down here. All right, now let's do an example problem here. So as you can see, it says y equals 2 cosine 4x. So this is a transformation from cosine. The normal cosine graph looks like this. So the sine graph started from 0, cosine starts from 1. So this will be one full cycle for cosine from here to here. So now here I have y equals 2 cosine 4x, which means 2 here. This is my vertical stretch, and this is my period 4, which means I have 4 cycles instead of just 1. What that means is I will be compressing the graph horizontally, and then here I'll be stretching it vertically too. Factor of 2 stretched, compressed horizontally by a factor of 4. Now let's look at this graph. Let's try to make this graph. So I am stretched vertically by a factor of 2, compressed horizontally by a factor of 4, which means okay. Instead of starting like I did up here at 1, I need to start at 2. So I'm starting here, and then compressed horizontally by a factor of 4, which means I need to come in here like this. And I know that I'm 2 pi over 4, which means one full cycle will be at pi over 2. So this shape here needs to be made from 0 to pi over 2. And you can see that's how it is right here. So that's one full cycle there, 2 full cycles, 3 full cycles, and then 4 full cycles stopping at 2 pi.